Hello, and welcome back to another Python interview practice problem. This is another one off of the top interview 150, and this one is the evaluate reverse Polish notation. So, I just want to show you kind of how Polish notation works, and give a little pseudocode for how we're going to handle this. Well, first let me get the test case here. So let's use example 2. So we have these tokens for 13, 5, and then a division, and then a plus sign. So what we have to do is we have our tokens, right? We have our 4, 13, 5, division, and our plus sign. The way reverse Polish notation works is we do the operations in so like we take here for this will be our first operation because the first sign we reach is the division sign. So then we will have 13 divided by 5, which will give us 2. So then this is what's going to be left. And then we'll do 4 plus 2 to give us 6. So that is all well and good. But designing an algorithm we're going to have to use a stack. That's going to be the best way to do this. So we have our tokens, right? So we have tokens again. For 13, 5, division sign, and addition. So then we're going to have our stack. So we're going to add the numbers onto the stack until we reach an operator, right? So what we'll do here is we have our stack. We're going to add 4, 13, 5, and then we're going to reach an operator, right? When we reach the operator, we're going to use the operator on the top 2 elements on the stack. So you're going to need to pop off the 5 for the right side and the 13 for the left side. And then we're going to push that back on the stack, the result of that. So we have 4 and then 2. And then what's left in tokens at that point is just the addition sign. So then when we reach the addition sign, we're going to add together the 4 and the 2 to give us 6, which is the result we're looking for. So let's get into implementing that algorithm. So we're gonna make variables to hold on to the left-hand side and the right-hand side. I like doing this just because I would rather just keep the variables in an outer scope rather than continually creating them and destroying them. And so, one thing I didn't show in the pseudocode is that we're gonna to get these elements first, get the 4, the 13, and the 5 first. We're just gonna reverse the list so we can pop them off the end easily. That'll be easier than taking them off the front. So to do that, we'll use list splicing. And so we're telling it to take the whole list, but just to reverse it. That's what the -1 says, every element but backwards. So because the splicing is index you want to start at, index you want to end at, and then how many you want to jump between indices. So again, just defining some variables, and then so we're going to say while we have elements and tokens, we're going to say current is equal to tokens.pop. So we're popping off the end of the list. And we're going to say if current is equal to multiplication sign. And multiplication is commutative, so we don't have to worry about the left-hand side and right-hand side here. You can just say stack plus equals stack dot pop times stack dot pop. Oh, and we want to put that inside of the list, so we can append these lists together. That's just an easy shorthand way of adding to the end of a list. And then we'll say else if we have the division operator, and division is not commutative. So we have to take the right-hand side and set that equal to the element we pop off the stack, and then the left-hand side for the next one. And then we're going to add to the stack left-hand side divided by right-hand side. Now the division here is a little bit weird with the negative numbers. So the problem is in Python, if you divide by a negative number and it gives you a it's always gonna round down if you use this operator, the integer division operator. So even if you're doing negative numbers, it's going to it's not going, like it says here that we need to truncate towards 0. Always the division between two integers always truncates towards 0, even if we're dealing with negative numbers. So this needs to go, this needs to round 0, not to -1. So to handle that, what we're going to do is if it doesn't divide in evenly, which is we use the modulus operator for that. If left-hand side modulus right-hand side is not equal to 0, and left-hand side integer division right-hand side is less than 0, then what we're going to do is we're going to take the last element we put on the stack, and we're going to add 1 to it. And this just gets the last element of the list. So it'll go toward 0 rather than always rounding down. So then we're going to handle addition. And we're going to, again, addition is commutative. So we can just say stack plus equals stack.pop plus stack.pop. And subtraction is not commutative. So we're going to say current is, so we're going to, again, we're going to use right-hand side and left-hand side. And then we're going to say stack plus equals left-hand side minus right-hand side. Else, so then we're going to handle if we have an integer. So if it's not any of these characters, then we must have an integer. So what we'll say is stack plus equals, since it's going to be in a string, see these are strings here, we're going to we're going to cast it to integer and then add our current token. And that's it, really. So after the full loop, we'll just have one element left on the stack, just like I showed you. When we pseudocoded it. So we just return the last element on the stack, and let's give that a shot. And there we go. Thank you all for watching, and I'll see you next time.